students. Once again, by the names of Chiwokaso Bikufachi, a teacher of mathematics. Today we are going to look at matrix. I want us to continue from where we stopped. We had covered the matrix, that is the determinant of a 2 by 2 matrix, whereby it is given by product of major diagonal minus the product of minor diagonal. Today, I want us to look at singular matrix. A singular matrix, by definition, these are matrices. These are matrices whose determinant is 0. These are matrices whose determinant is 0. We can have an example here. We have a 2, 2, 2, 2. When you look at this matrix, its determinant is 0. This one gives a 4, and also here 4. We can have another one, 2, 3, then 2, 3. Even this one, its determinant is 0. Next we can have 2, 5, then 10, 1, etc. Also this one, its determinant is 0. This is our first definition. We can also say singular matrices. These are matrices which have no inverse. All their inverse is infinity. Let us look at an example here. Find the values of x for each case. If the following matrices are singular. Let us have number 1 here. We have x 3, this is a 4, 2. Matrix M equal to x 3, 4, 2. They want us to find the values or the value of x given that the following matrices are singular. By definition, a singular matrix, its determinant is 0. So in our solution, we shall say that since M is singular, matrix, this implies that determinant M equal to 0. It implies that determinant M is 0. So how do we get a determinant? The determinant is given by product major minus product minor diagonal. So let us say that 2 into x, that is our major diagonal, minus 3 into 4, the answer is 0. Why is it 0? It's because it is a singular matrix. By multiplication, this is 2x minus 12 equal to 0. What was the question? They want us to find the value or values of x. For such case, we shall say minus 12 plus 12 equal to 12. Add the 12 on either sides. This means that 2x equal to 12. We are supposed to find the x. How do we find the x? If we have 2x equal to 12, we shall divide by 2 on either sides. So, in our conclusion, we shall say therefore x equal to 6. Because we have divided by 2, it gives x. By 2, it gives 6. Allow me to give another example. Allow me to give another example. Allow me to give another example. Case 2, that is Roman number 2. We have x, and this is 3. This is 2. Then here we have x plus 5. This is matrix P. They want us to find the possible values of x given that matrix P is singular. Given that matrix P is singular. For that case, allow me to get the determinant of P. But before we talk about determinant, let us say we shall quote, since P is singular, since P is singular, this implies that determinant P equal to 0. Determinant is product measure, that is x into x plus 5, minus product minor, that is 3 into 2, it gives a 0. Let us open brackets. Let us open brackets. We shall say x times x, that is x squared. Then x times 5, it gives a positive 5x. Negative 3 times 2, it gives negative 6 equal to 0. When you look at this expression, this is a quadratic equation. This is a quadratic equation of which we are supposed to identify the sum and the product. So for that case, our sum is 5 and our product is negative 6. Identify the common factor. Get the two numbers such that when you add, they will give us a sum of 5. And when you multiply, they will give us a product of negative, that is negative 6. So we need to check within the factors of 6. We check within the factors of 6. Somebody can say 1 and 6. 1 and 6, when you look at 1 and 6, we see that there is a 5. Let us take 1, 6. But identify which of the two numbers should have a minus sign, such that when you add it gives a positive 5, that is negative 1. So it is negative 1, 6. It gives a product of negative 6 and also gives a sum of positive 5. Let us substitute negative 1, 6 where there is 5. So this is x squared minus x plus 6x minus 6. This one gives a 0. What does the question calls for? We are interested in the values of x. Let us identify a common factor here. So when you observe, we have x into x minus 1. So here we have positive 6. This is 6. X minus 1. This is 0. So the two brackets are common. That is x minus 1 into x plus 6. This one gives a 0. What does the question calls for? We are supposed to find the values of x. For either x minus 1 is 0 or x plus 6 is also 0. Let us summarize by saying that therefore the x value is positive 1. When it is negative, it means that x is supposed to be positive. So here we have positive, meaning that the x value should be negative 6. Negative 6. Allow me to give another example here. Allow me to give another example here. So, when you observe here, we shall give 4 marks or 5, depending on the setter's interest or on the marking guide. Let us look at example 3. We have matrix M equal to X. So this is 10. Here we have 3. This one gives the x plus 1. They want us to find the possible values of x. Let us have that. They want us to find the possible values of x. Given that matrix M is singular, we shall say that since M is singular, this means that determinant M is 0. How do we get the determinant? We say product measure, that is x into 2x plus 1, minus product minor, diagonal, that is 10 into 1, but it should give us a 0. When you observe here, we have 2x squared plus x minus 10 equal to 0. We shall factorize. We see that our sum is 1. There is a 1 there. Plus the product. We shall multiply this 2 by negative 10. That one gives the negative 20. Common factor. We shall check within the factors of 20. We see that there is 10 and 2. 10 and 2 cannot help. But we can use the 5 and 4. We have 5 and 4. But when you add, it gives a 9. So let us modify. It should be negative 4, positive 5. We shall substitute in. We have 2x squared plus 5x minus 4x minus 10. This is 0. Observe, there is a common factor here, that is x. So it is x into 2x plus 5. We also observe here there is a common factor, that is negative 2. We shall say negative 2 into, divide here by negative 2, it gives the positive 2x. Divide by negative 2, it gives the positive 5 equal to 0. Let us identify the common factor, that is 2x plus 5. We say that 2x plus 5, then x minus 2. This one gives a 0. We are interested in the values of x. We are interested in the values of x. Allow me to use this space. We shall say that x, when you equate this one to 0, x to be negative 5/2. You may reduce it, or you may leave it in that form, or you may give your answer in decimal. That is the first x value. The second x value, that is x minus 2 equal to 0, and our x value is 2. Lastly, allow me to give another example here. We are dealing with a singular matrix. Example 4, we have matrix R equal to x minus 1, then x plus 1. Here we have 5, 7. They want us to find the possible values of x, given that matrix R is singular. For this case, we shall quote that since R is singular, O has no inverse, You should know these two terms, singular and has no inverse. It takes the same meaning that the determinant of R is 0. The question is undone. Let us get the determinant of R. We say that the determinant is given by product major minus product minor diagonal. So dear students, we shall say that the determinant are equal to product major diagonal minus product minor diagonal. This one gives a 0 because it is a singular matrix. It is a singular matrix. So when you observe, this one calls for application of difference of two squares, of which we shall have x squared minus 1 squared. By 1 squared, it is the same as 1. Minus 35 equal to 0. When you look at this, we have a date of 1 and a date of 35. That one is minus 36. Let us go ahead to apply difference of two squares. Which number do we square to get 36? That number it is 6. So this is x squared minus 6 squared equal to 0. We say that x minus 6 and x plus 6, it is, for either x minus 6 is 0 or x plus 6 it is 0. We are interested in the values. Of x. Allow me to say, therefore x1 is 6 and x2 it is negative 6. So those are 4 marks. I want you to try out this activity. during your free time. but try to use the given example. Try to use the given examples. Try to use the given examples. This is activity. This is our activity. We say that find the unknowns. Let us, given that the following matrices are singular or has no value, Given that the following matrices are singular or has no inverse. It should be has no inverse. Dear students, we have question here that is 3T, then 5, 6. Next, N, that is A, x plus 2, Then here we shall have 8, 6. Next, number 3, we have P equal to x plus 1, x. Then we have 10, 3. Lastly, we have R. It is x plus 1, x minus 1, and also 8. Let it be 16. So I want you to try out that activity using the given example here. Follow this given example properly. They say the matrix R is singular. We said that since R is singular, it has no inverse. Meaning that the determinant is 0. Get the determinant and equate it to 0. From that part, I want us to look at inverse of a 2 by 2 matrix. I want us to look at inverse of a 2 by 2 matrix. A 2 by 2 matrix. The inverse of a 2 by 2 matrix, it is denoted by, let us say, inverse of matrix. Say M is denoted by M to power -1. Dear students, once you find the M to power -1, this one calls for inverse. It calls for inverse. Let us have an example here. Let us have an example here. Given, this is number 1, given that matrix M equal to, given that matrix M equal to 3, 2, 1, 2. Okay? Find M inverse, or find the inverse of M. Dear students, to find the inverse, you need to know how to get the determinant. You need to know how to get the determinant. Okay? We say that M inverse equal to 1 over determinant M times the adjunct M. We said that M inverse equal to 1 over determinant M times adjunct M. We had covered how to find the determinant. Let us recall. We say where determinant M, it is a product major diagonal minus the product minor the diagonal. That's how we get the determinant. Next, for adjunct M, for adjunct M, we interchange elements within the major diagonal. We interchange elements within the major diagonal. We interchange elements within the major diagonal, and we change the sign of elements within the minor diagonal. Take an example. We have a matrix here. Then here we have the adjunct or semi-inverse. Adjunct or semi-inverse. Case 1, we have A, B, C, D. Its adjunct, it is going to be D, negative B, negative C, and this is A. We said that interchange positions in the major diagonal. It is done here. We see that D is replacing A and A is replacing D. Last the minor, change the sign. We see that we have positive, meaning that here we have negative. Allow me to give another example here. We have 3, negative 4, 5, 10. That is our matrix. What about its adjuncts. Interchange position of elements within the major diagonal, meaning that we are going to have 10, 3, whereas the minor change the sign. This is positive 4, negative 5. The sign of 4, it has changed into positive. Whereas the 5, which was positive, it has changed into negative. Back to our question, which is here. They told us, given that matrix M equal to, find M inverse. For that case, allow me to get the determinant of M. Allow me to get the determinant of M. We say that determinant M, it is the product measure, that is 3 into 2 minus product minor. Product, it means a multiplication. What is 2 times 3? This one gives a 6. Then 2 times 1, this one gives negative 2. So here we shall have 4 as our determinant. What about the adjunct of M? Adjunct M, we say that interchange position of elements within the major diagonal. So this is 2, 3, whereas the minor changes the sign. We shall have negative 1, negative 2. But that is not the final answer. We go back to the question. They want us to find the M inverse. They want us to find M inverse. We say that M inverse, it is 1 out of determinant M times adjunct M. What does it mean? We know our determinant. So this is 1 out of 4. 1 out of 4 into the adjunct, that is 2, negative 1, negative 2, 3. However, this is not the final answer. This is not the final answer. We shall say that our final answer is, this is a scalar multiple. And this scalar multiple, it is supposed to affect each and every element within the brackets. So our answer is 2 over 4, negative 1 over 4, negative 2 over 4, and 3 over 4. You may reduce your answer. You may reduce your answer, or you may leave it in that form. However, avoid giving your answers in decimal. If you are to give your answer in decimal, make sure it is to 4 decimal places. So it is better to leave your answer in that form, or to simplify it further. That means you reduce. You reduce. I want to give one more example. Number 2, question 2. A4 matrix A is 3, 2, 0, 4. Then P, matrix P is 1, 3, negative 2, 1. And C equal to trace A minus b. We said that this 2, it is a scalar multiple. That 2, it is a scalar multiple. Find Roman number 1, matrix C. Roman number 2, C inverse. C inverse. Let us say solution. Case 1, C equal to trace A plus B. This is 2 into A. Matrix A is 3, 2, 0, 4, minus B, that is 1, 3, negative 2, 1. This 2 is a scalar multiple. It affects each and every element within the given bracket. By multiplication, we have C as 64. This is 0, 8, minus 1, 3, then negative 2, 1. Negative 2, 1. We subtract. We subtract the corresponding elements. That is 6 minus 1, it gives a 5. 4 minus 3, that is positive 1. 0 minus negative 2, positive 2. Allow me to repeat that. We said that 0 minus negative 2. A negative and negative, it gives a positive, that is addition. That's why we have positive 2. 8 minus 1, this one gives a 7. That is matrix C. Let us look at Roman number 2. They say C inverse. This is 1 out of determinant C times the adjunct C. When you observe, the inverse is given by product measure, that is 5 into 7 minus a product minor, that is 1 minus 2 into the adjunct C. For this case, we interchange the elements within the major diagonal. That's why we have 7, 5. We interchange elements within the major diagonal, whereas we change signs in the minor diagonal. This is negative 2, like that. When you observe, this is 35 minus 2, it gives 1 over 33. I repeat that. 5 times 7, 35. Minus 2, 33. This is 7, negative 1, negative 2, 5. The answer is 7 over 33. Also, negative 1 out of 33. Then here, negative 2 over 33. Here, 5 over 33. So, with those examples, allow me to give another activity that is under inverse of a 2 by 2 matrix. Inverse of a 2 by 2 matrix. We shall have an activity here. We shall have an activity. Number 1, find the determinant of the following matrices. Case 1, we have P equal to 5, 1, 3, 2. Case 2, we have R equal to 2, 4, 7, 1. Case 3, we have N equal to 7, 5, 6, 5. You find the determinant of those numbers. Lastly, that is question 2. That is question 2. Try to do that work by using the given examples. Question 2, find the inverse of the following matrices. Find the inverse of the following matrices. Number 1, we have 2 equal to 10, 2, 5, 3. Next, M equal to 6, 4, 5, 2. We shall have the last one here, that is 3, N 0, 2, 1, 5. So, do that work during your free time using the given examples. So here, we are going to look at multiplication of matrices. For this case, we always multiply a row by column. For this case, we always multiply a row in that arrangement by column. A row by column in this form. E.g., we can have a 2 by 2 times a 2 by 2. We say that that is compatible or it is workable. Next, we can say a 3 by 2 times a 2 by 3. Since these two numbers are the same, we can get the answer. Even here, allow me to look at this one. Roman number 3, we have a 5 by 3 and a 3 by 2. If these two numbers are similar, you can go ahead to multiply. Okay? You can go ahead to multiply, and the outcome it will be a 5 by 2. A 5 by 2. But if we have, let me say, a 2 by 2 times a 3 by 5, This is the incompatible. These two numbers are not similar. Those two numbers are not similar. Meaning that a column should be similar to this field. Okay? So this is the incompatible, unworkable, and so let us have an example. Let us have an example here. Example. Work out the following multiplication. The following multiplication of matrices. The following multiplication. Case 1. Case 1, Roman number 1, we can have 3, 4, 5. We said that this field is a scalar multiple. So every number within it to be multiplied by 3. And this is a 2 by 1. So the answer should also be a 2 by 1. That is Roman number 1. That is Roman number 1 over number 1. Roman number 2. If we have 4, then it's 7, 8, 9. This is a 1 by 3. But that effort is a scalar multiple. What does it mean? Every element within it will be affected. That is 28. And this is 32. This is 36. This is a 1 by 3. Leave a space in between. Okay? It is a sign that you are dealing with the matrices. Let us have another case here. That is number 2. Number 1, we have AB, then XY. In that arrangement, this is a 1 by 2, and this is a 2 by 1. We see that this it is similar to that 2. We can multiply and we get the answer. That is a row by column. Okay? You stand like this, then it goes down. That is AX plus BY. The answer is 1 by 1. Let us utilize example 2. We have 3, 1. This is a 1 by 2. Then we have 2, 5. This is also 2 by 1. We can multiply that and we get the answer. 2, that is 3 times 2, plus 1 times 5. Our answer is 6 plus 5. This one gives 11. This is a 1 by 1 matrix. It is a 1 by 1 matrix. Let us have this one also. Number 3. We have 1, 0, 1. This is a 1 by 3 times 2, 5, 4. This is a 3 by 1. We are dealing with the multiplication of matrix, of which we always multiply a row by column. This one gives 2 times 1 plus 0 times 5 plus 1 times 4, and this is 2 plus 0 plus 4. The answer is 6. And this is a 1 by 1 matrix. A 1 by 1 matrix. Allow me to give an activity here. Allow me to give an activity here, which should be done during your free time. Work out the following. Work out the following. We have 3, 1, 2. Next, we have a half. This is 4, 6, plus 1, 2. Like that. Next, we have 5, 4, and this is 10, 3. Try out to that during your free time. Thank you for being part of this session. Once again, I'm by the names of Shivukaso Bigfachi. In case you have any problem, you can get me on this number, but that is on WhatsApp. But I prefer you use Telegram X. You use Telegram X. Thank you.